Good morning or good afternoon. It's Miss Bauer here, and today we're going to talk about graphing quadratic functions that are in standard form. Now, standard form is f of x or y equals ax squared plus bx plus c. Okay? From standard form, you can very clearly see a, like we've been doing, right? And then c is your y-intercept. So if you have it in standard form, you can easily see that c is going to be your y-intercept. So that's 0, comma c. So that's 1 point. And then to find the vertex in standard form, you have this formula. So to find the vertex, x will equal negative b over 2a. And then you take that and you plug that in to find your y value. So f of negative b over 2a is going to give you your y value, or the k part of the vertex, and that's how you find the vertex. Now, remembering back to all the graphing ones that we've done, I'm still going to use that run rise because this is your x and this is your y. So remember that a is going to help you out with the run rise to find some other points. So remember that it went over 1 up 1, over 2 up 4, because 2 squared is 4, over 3 up 9, over 4 up 16, over 5 up 25, so on and so forth. So I'm still going to be kind of using that rule to help me graph these, okay? So taking a look at this first one, it says graph y equals 2x squared plus 8x minus 2. Now, for the transformation, I know that it's going to be vertically stretched by a factor of 2 because I know that a is 2, but I really need to figure out where my vertex is at. And I know that it's going to open up because a is positive, so I know that it's going to have a minimum. Okay? I also know that my domain is going to be negative infinity to positive infinity. And because it's in standard form, I already know my y-intercept because that's just 0, comma c. So my y-intercept is going to be 0, negative 2. But then to really put this on a graph, I'm going to have to find my vertex, axis of symmetry, all of that. So x equals negative b over 2a. And remember that you do have to memorize these formulas, which is why you hopefully still have that pink paper with those on there, okay? So negative b would be negative 8, okay? Notice that your formula was like ax squared plus bx plus c. So you don't have to worry about how with vertex form and intercept form, you have those negatives you just switch over. This is just, it is what it is. So negative 8 over 2 times a is 2. 2 times 2 is 4, so negative 8 divided by 4 is negative 2. Now, be really careful with your positives and your negatives here, because if you mess up the h part, the x coordinate of your vertex, or h, right? Now your y is going to be off, okay? So now I'm going to find y, so y equals 2 times negative 2 squared plus 8 times negative 2 minus 2. Well, negative 2 squared is 4, so 2 times 4 would be 8. And then 8 times negative 2 would be minus 16 minus 2. So you have 8 minus 18, which is going to be negative 10. So there's your minimum, negative 10. And we know that our vertex is at negative 2, negative 10. And our axis of symmetry would be x equals that x coordinate, so x equals negative 2. And because it was a minimum, now I know my range is negative 10 up to infinity. Okay? So this should be a u, just like the parent function, a parabola, right? Quadratic, but I know that it's vertically stretched. And based on the vertex, it's going to translate left 2 down 10. So I'm going to start with my vertex, so left 2 down 10 right there, okay? I know that my y-intercept is at negative 2. And so if I have my axis of symmetry through the vertex, I can reflect that point. So like if this was 2 away, right? I'm going to go 2 and then there's my other point right there. So don't forget to use that axis of symmetry through the vertex, and that's going to help you reflect to give you 5 points total. So you really just need to find 2 on one side and reflect them to get 2 on the other side. Okay. Now, a was 2, so back over here, instead of going over 1 up 1, now I'm going to go over 1 up 2 because it was vertically stretched. So now I'm going to go over 1 up 2, and then I can go to the other side over 1 up 2 or just reflect it. And then there's your parabola. That's it. Now, if it asked you to find the x-intercepts, okay, these aren't my x-intercepts. My u wasn't super accurate, but to find the x-intercepts, remember that you could just set y equal to 0. So you could do 0 equals 2x squared plus 8x minus 2, and then ask yourself, do you want to solve by factoring? You can't solve by square root, so do you want to do completing the square, okay, or do you want to do quadratic formula? Okay, for time's sake, I'm not going to go back through all of those methods. There were previous videos on those. But if you do have to find the x-intercept and you can't tell from your graph, remember, you've got all of those options that we previously went over. Okay, taking a look at this next one in standard form, I can see from this plus 6 that my y-intercept is going to be at 0, 6. I can see that A is negative, so my parabola is going to open down, which means that I have a maximum. And I know my domain is going to be from negative infinity to infinity. That negative is going to reflect it, so I can also go ahead and write reflects over x-axis because it's opening down. And then the 3 is going to make it vertically stretched. But I need to figure out the vertex to find everything else, okay? So x equals negative b over 2a. So that's going to be 4 over 2 times a is negative 3. 2 times negative 3 is negative 6. That's going to simplify to be negative 2/3. Now, there's a reason that we stick to fractions instead of decimals. Negative 2/3 is negative 0.6 repeating. So if you're plugging in 0.6, that's not the same. Those aren't the same thing, okay? So I'm going to plug this in and we're going to practice those fraction rules. So I'm going to find f of negative 2/3, okay? And I already know my axis of symmetry, right? Because I found the x-coordinate, x equals negative 2/3. I have half of my vertex, it's negative 2/3, okay? But now I need to figure out my y value to do everything else. So I'm going to have negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6. Now, negative 2/3 squared is going to be positive. 2/3 times 2/3, that's going to be negative 3 times 4/3. 4/9, sorry, y'all. Because 3 times 3 is 9. Okay, so that's negative 3 times 4/9, okay? Right here, this negative and this negative are going to become a positive, so that's going to be plus. I don't have a fraction, it's just 4 times 2/3, so just do 4 times 2, which would be 8/3 plus 6. Okay, now I'm going to need a common denominator. So right here, this negative 3 times 4/9, that multiplies your numerator, so that's negative 12/9, and then negative 12/9 would reduce because 3 goes into both of those. So that's just going to be negative 4/3 plus 8/3. So I really just need the 6 to become something thirds. 3 times 6 is 18/3. So negative 4/3 plus 8/3 plus 18/3 is going to be 22/3. So 8 plus 18 made 26 minus 4 is 22/3 positive, okay? So there's my y value, 22/3. So my range, if that was the maximum, is going to go from negative infinity up to 22/3. And then my max is at 22/3. Now, 22/3 would be 7, because 3 goes into 22 7 times, that'd be 7 1/3. So my vertex is going to be at negative 2/3, which would be a little bit more than halfway, and then 7 1/3, which would be like right around there. Now, my y-intercept is at 0, 6. So you can go ahead and reflect that over if you want to, or you can also just plug in values to give yourself easier points, okay? So if you're having trouble with this, if you go back up to your original and then let's just plug in negative 2, that would be negative 3 times negative 2 squared minus 4 times negative 2 plus 6. And then you're going to have a much clearer point, okay? So negative 3 times negative 2 squared, that would be 4. So that'd be negative 12. That would be positive because there's two negatives. So negative 12 plus 8 plus 6. So that's 14 minus 12 would be 2. So that would be negative 2, 2 as a point. And I messed up somewhere, y'all, so give me 1 second. I'm just trying to catch it. Negative 3 times negative 2 squared, 4. 2. I'll catch it in a second. But you can plug in points and get your values from there. So you can do that. What you can also do is you can just use this as your axis of symmetry and then flip things over. So you can kind of estimate it, and with graphs like this, it's going to be okay with me if it's not perfect. So this was 2/3 this way, so that would go 2/3 that way, so that would be like right around there. Okay, and then you can just plug in points if you're having trouble and kind of go from there. So I'm going to pick a different point to plug in now. I'm going to go ahead and plug in 1. So now I'm going to come back up here, so I'm going to have negative 3 times 1 squared minus 4 times 1 plus 6. So negative 3 times 1 squared would just be negative 3 minus 4 plus 6. So that would be negative 7 plus 6, so that would be 1. Negative 1. So it's going to end up looking like this. Maybe this was right, y'all. Right around there. Just like that, okay? Now, I'm not going to give you a ton of ones with fractions, but you do want to make sure that you know your fraction rules and you have some idea, right? Okay, and then back to the last part of our transformation. This is going to translate left 2/3 and up 22/3, okay? So moving on to another one, taking a look right here. Okay, based on what I have from here, before I even graph, I know some things, right? I know my y-intercept because that's this c value right there. So I know my y-intercept is going to be at 0, 3. I know my domain is going to be from negative infinity to positive infinity because it is for all of them. And I know that because a is just 1, it's going to open upward, and so it's going to have a minimum. Now, where is that minimum at? That's where I have to go back and follow my formula. So x equals negative b over 2a. So that would be negative 2 over 2 times a is 1. Negative 2 divided by 2 is just negative 1. So now I'm going to plug that in. So I'm going to find g of negative 1, and that's going to tell me the y-coordinate, and then I'm going to have my vertex, okay? So that would be negative 1 squared plus 2 times negative 1 plus 3. So negative 1 squared would be 1. 2 times negative, I want to make that minus 2 plus 3. So 1 plus 3 is 4. If I subtract 2, that's going to give you 2. Okay, so your vertex would be at negative 1, 2. That means your axis of symmetry would be at x equals negative 1. Okay, we know it has a minimum at 2, and then it's going up. So it's going to start at 2 and then go up to infinity. And then this wasn't vertically stretched, compressed, reflected, none of that. So I know that this is going to translate left 1 and up 2. So this is going to translate left 1 up 2. There's your point. I know my y-intercept's at 0, 3. It went over 1 up 1. And then I can reflect it. Remember, there's your axis of symmetry. So I can go over here and do the same thing. Okay. And then it wasn't vertically stretched or compressed at all. So then I'm going to go over 2 up 4, over 3 up 9. Take your pick. So I'm going to go ahead and go over 2 up 4. So over 2 up 4 would be right there. And then left 2 up 4. So I just went over here up 2, 4, and then over 2, 4 to reflect it across that. Okay. And then there's your parabola. So let's take a look at one more. I see that this is a -2, so this is going to be going down, which means I'm going to have a maximum. I know my domain's going to be from -infinity to +infinity, okay? My y-intercept's going to be at 0, -5. And then I'm going to need the vertex for everything else, okay? So x equals -b/2a. So that would be -2 over 2 times a is -2. Well, that's -2 over -4. That would be +1/2 because 2 negatives make a positive, okay? Now, you could use 0.5, but for practice, we're going to keep using the fractions. So now I'm going to find h of 1/2. So that would be -2 times 1/2 squared plus 2 times 1/2 minus 5. Okay, 1/2 squared would be 1/4. So then I have -2 times 1/4 plus 2 times 1/2 is just 1 minus 5. And then this right here is going to mean I'm going to convert everything to fractions. -2 times 1/4 would be -1/2. That'd be -2/4, which is just -1/2, plus 1, which would be 2/2, minus, not 5/2, but that would be 10/2, because 10 divided by 2 is 5. So I have -1/2 plus 2/2 minus 10/2. So looking at your numerators, what's -11 plus 2? Think of it that way. Well, that would be -9/2. So there's the y value of your vertex. So my vertex is going to be at 1/2, -9/2, which means your axis of symmetry is at x equals 1/2. We said that that was a max at -9/2. And because it's going down, that means that your range is going to start at -infinity and go up to -9/2. And then for transformation rules, that negative is going to reflect it over the x-axis. That 2 is going to make it vertically stretched. And hopefully you're getting kind of faster at these transformation rules. So vertically stretched. And then it's going to translate right 1/2 and down 9/2. Okay, so right 1/2 and down 9/2. That would be right 0.5 and then down 4.5. So that would fall right here for your vertex. Remember, you can have things in between the points. Now, you know that your y-intercept's at 0, -5. So that was here. And then that would reflect, so there's 3 points. Now I only need 1 more point. So I'm going to plug in 2. I could also plug in -1. I could plug in 3, 4. I'm just going to kind of keep working around. And I would much rather plug in a +2 than a -1. So back up to our original. So I'm going to plug in 2 because I need 2 more points on this parabola. So I'm going to do h of 2 equals -2 times 2 squared plus 2 times 2 minus 5. So -2 times 2 squared, that would be 2 squared is 4. That would be -8 plus 4 minus 5. -8 minus 5 is going to be -13 plus 4 would make h of 2 equal -9. So your next point is going to be 2, -9. So 2, -9 would go here. And then if this was your axis of symmetry, if I reflect over that, then that other one would be 1.5 over. So that would fall like right around there. So notice I went like 1.5 this way, so I'm going to go 1.5 that way. So it should be here, my bad, y'all. And then there's your parabola. Okay. If you're having trouble with the fractions, it's going to be okay to convert those to decimal. It's also okay on these like kind of tricky ones to draw your axis of symmetry in and then just plug in points. Like you can plug in 2 and -1 and go from there if that's easiest for you to get points. Okay. And we'll pick up with part 2, not with graphing, but how do you convert them between the forms now that we've looked at standard form, intercept form, and vertex form. I'll see you in the next one.